we don't know, we'll just say it was Atlanteans.
Exactly.
The Atlanteans did that. All right, so let me give you guys one to try. Convert 2016 to base 16. So who what?
Inca had a base 10 too.
Dude, yeah. A lot of civilizations had number systems that used 10 in some way. A lot of them influenced each other, but, you know, they were taken over by other people and so forth, right? Base 20, you should look up base 20. That's using your hands and your feet. There's quite a few civilizations that use base 20. All right, so how do I start this off, guys?
1, 16, 256. It's like 4,000 or something.
4,000?
4,496.
Gotcha, I like it. So go that next step so you know that that's far enough. So that is far enough because the next one's too much. Now tell me, real quick, what was that number again?
4,096.
4,096?
4,496.
4496, okay. I get people that make a mistake. They take this number and they divide it by that. Can you see that? That's a mistake. Because I'm trying to take this number and distribute it across these. But then they take that number and divide it by that and they think everything's great. And well, in that case, you just keep going. You can just keep going. You'll never stop. And holy crap, I'm still on problem number 1, John. No. What you do is you always divide the number you're given by the place value. That's why you stop when it's too big of a number, when it won't go in. 256 goes into 2016 7 times. 7 times 256? 1792. That sounds like a history quiz. 224? Is everybody with me?
Yeah.
Divided by 16?
It's just 14.
14?
D.
Exactly 14?
Yeah.
Sweet. And then how many ones do I need then?
0.
None. Thankfully I have the symbol for 0. So how would I write that then correctly?
7 new 0. 7 new. Oh, 13.
So I need E, right?
Oh, 80.
A is 10, B is 11, C is 12, D is 13, E is 14, so it's 7, E, base 16, 0, Jeff. You need a 0 in there, buddy. 7 EO.
So what number is that?
It's 2016.
That's just 2000. Just weird.
Yeah, totally. Very strange. So if you looked up HTML code for colors, you would see stuff like F. So I can't remember now. There's 4 or 6. And F would mean, and each of these places represents like red, blue, green. So F would mean all of each. So it would come out to be, in this case, I can't remember if it's black or white, which way it goes. Black. So it's all the colors at once, so it'll be black. So if I put 0, 0, 0, 0, 0, F, it would be purely that color, whatever color that was. So that's a side note, if anybody's at all curious. That's how HTML uses it, because then they can have codes for a huge scale of colors, right? Not just your basic little tiny pack of Crayola crayons. Right, I'm talking about the mega one with like 3 freaking sharpeners on the side and shit. Right, I'm talking about a lot of colors. Right. Okay, maybe.
So when you get into a base that goes past O, then what? How do you do zeros and O's to the same?
Yeah, I guess you're not going to pick O, right? In fact, I would have trouble with anything that used T or S, because that looks like 5, right? L and I, oh crap, that looks like 1, and who knows, right? So if you're using a base that uses that many, you probably created your own numbers and your own symbols. So people that use bases that go higher, they'll use different symbols than these, right? They could even, well, I've seen people use like x1, x2, x3. That gets kind of stupid, right? Because that's like, well, you're writing too much. You're writing more than you have to. You with me?
Yeah.
Okay. But I like the idea. There's a lot of different ways to do it. As long as you communicate that idea to other people that have to look at your shit, then everybody agrees, and then you're good, right? That's how you create mathematical stuff. Okay. So if I said this, I like to give you this kind of problem. What's wrong with this? Is there anything wrong with this number here?
Yeah, have 7.
Yeah, 7. Base 7 can't have 7. Nah. But I've had people tell me like 12, 4, 7, base 11. Is there a problem with that?
No.
See, I'm being a little tricky. People tell me there's a 12. No, there ain't. There's a 1, a 2, a 4, and a 7. And they're all allowed in base 11. I like it. Okay, I like it. Good. Sweet. All right. What about base 1? What's up with base 1?
1 and 0.
Well, think about it. That'd be the ones place.
It's just
Stage
italics.
1.
It's just italics.
1 squared place, right? So there's 2 things that are weird. You can only have 1 symbol, if you think about it. Right? So you can either use the symbol 0, which is no good, or you can use, because I mean, think about how many numbers, how many digits are you allowed to use in base? And somebody again, how many digits can we use in base 10? 9. So how many digits can we use in base 1? 0. So you do have to kind of break the rules and say, I want to use the number 1. And then, like you said, it would be just a tally system. So if you want to represent the number 7 in base 1, it would be 7. It would be that, right? I like it. So there is no freaking base 1. Right? Just like there's no first root. What would the first root of something be?
The number?
Itself. Yeah, so that would be silly, right? Why would I do that? It doesn't really do anything for me. All right, just want to blow your mind a little bit. Okay, there's one last thing I want to talk about today. If I could just remember what it was. There are some problems in the homework that give you, I don't have the most colors in the world, but to play with. But if I said this was 0, this was 1, this was 2, what base do I probably have? Base 3, I like it. So then if I said what number is this? What does that represent? Well, you said I'm in base 3, right? So what places are these in?
1, 3, 9, 27.
Good. So how many 27s do I have?
1.
And so forth. You guys see? So I can use colors to represent different. They're symbols. I can use them as symbols to represent digits, like I do with these differently shaped things, right? Curve and straight lines make things that we see as numbers. Ooh, whoop-de-doo. I could use colors instead, right? A little evil if you have colorblind people in your society. That would be a little evil. So that's why it's not done. That's one reason why it's not done. Somebody looked up like the Braille number system last semester, and they tried to improve on it, which I thought was kind of cool because they had some relatives who were blind, right? So the Braille number system is interesting. Blah, blah, blah. I can't remember what it was. There was something else. Oh, well. That's too bad. A little preview, and then I'll let you guys out. That's all we do in chapter 4 is 4, 1, 2, 3. what we're going to get into next is a more detailed study of sequences, certain types of sequences. There's a section on Fibonacci sequence. Somebody was asking me about that earlier. You could actually devote, there's some people that devote huge chunks of their lives studying the Fibonacci sequence, and I'll give you a little taste as to why that might be true, because there's a lot of cool shit with the Fibonacci.
Is that the one in the seashell thing?
Yes, yes, and that actually is not the best example because it's, well, we'll get into it. It's not exactly what they say it is. But, so Fibonacci, I don't want to start talking about it now because then I won't stop. We'll also talk about these types of sequences here. Somebody tell me the main difference between these sequences here.
One's linear.
All right, I like that. You can represent it with a linear function.
One's additive.
One's additive. That's the linear one, which kind of makes sense. A linear function is one that you keep adding the same amount. Every time you take one step over, you add a certain amount. You take one step over, you add a certain amount. That's where slope came from. Right, so I like that. One's linear, meaning it's additive. I just keep adding the same amount.
Yeah, there's like multiplicative. Looks like you're multiplying by
I like it.
negative.
Beautiful. So this one's, the additive one is called arithmetic. And it kind of makes sense with the A, additive A, but then we lose that. Multiplicative, and see how, what's this keep multiplying by?
Negative
3. I like it. Look at you. So this multiplicative one is called a geometric sequence. Bless you. Obviously. Not obviously.
Yeah, geometry, shapes, multiplying.
Sure. Sides of a triangle, rectangle, whatever. So we're going to develop, I like that you said linear, we're going to actually figure out how to make an equation for these kind of sequences and these kind of sequences. Not just an equation to be able to predict the 217th element without actually having to go out to the freaking 217th element, right? We'll be in the corner, all work and no play makes you, no, I don't want that weirdness, right? No shining lever, okay. And we'll also make a function for this one, but we'll also figure out functions for both that tells me the sum of the first however many that I want to do. I think I showed you guys this here. Did I show you guys this here?
Yeah, Jeff, the 1, 2, 3, I've seen that.
If I said add up, I showed you that, right? Add up the first 100 numbers. And
Just add like the 199 and 2.
exactly. So I can do the same thing, even if as long as they're evenly spaced, meaning they're this kind of sequence, I could do this kind of thing. As long as they're evenly spaced, because then, so if I had to add, I would just add easily. This is 18, and this is 18, and this is 18, and this is 18. You see that? So as long as they're spaced evenly, as long as they're an additive sequence, I can use the same idea. So we're going to make a formula out of this. This one's going to be a little freakier. How do I represent the sum of the first however many of these? That's going to be a little bit more interesting. We're going to use nifty algebra. Can't totally escape algebra, sorry. All right. Otherwise, that's all I had. That kicks ass. So that's chapter 5. We'll get to chapter 5 next time. I think we should, before you guys are gone, let's have a quiz on 4.1 and 4.2.
Right now?
No. That is awesome. I want to do that someday before I'm dead. Before you leave, sit back down. 4.1 and 4.2 quiz Wednesday.
You want to do it, or do you want to?
On Wednesday, we'll have a quiz. 4.1 and 4.2. Yeah.
I'll let you know. Yeah.
That was funny. It's like worse than a pop quiz. Just y'all can leave. No, on second thought, take a